what is tblx? tblx stands for Trucks and Buses at Lisbon. We are a software company, obviously based in Lisbon, owned by Daimler Truck. We build connectivity services to bring data from vehicles to end customers, and also digital services that enable electric mobility for electrical vehicles. On the slides, you can check some fun facts about us. It will be available later if you want. Okay, and again, maybe some of you know, others probably don't know who Daimler Truck is. Daimler Truck is the company behind all these trucks and buses brand. If you ever watched American movies, you probably recognize the yellow school buses. Thomas built buses is a brand owned by us. And in Europe, our most known brand, probably worldwide as well, is Mercedes-Benz, trucks and buses. This is our agenda for today. First, we'll explain how data is collected and processed in Daimler Truck, why and what is our use case to use Flink. We will share some Flink essentials with you that we consider fundamental to start using Flink, and our learnings on the journey. Okay, we have a lot to talk about, so let's start by understanding what is IoT data at Daimler Truck. On the image, we have an Taro, an electric bus produced by Daimler Truck. This is just an example. Both buses and truck work in the same fashion when it comes to telemetry data. Our trucks and buses are equipped with a set of sensors that can give information about the vehicle, stuff, for example, like speed, GPS, battery, fuel level, and much more that I won't be detailing here because it's not needed. These sensors are constantly probing the vehicle, and the data produced by these sensors, we commonly refer to it as signals. The vehicles come with a built-in device called CTP, which stands for Common Telematics Platform. It's essentially a small computer that is connected to all the sensors in the vehicle and is able to collect the signals, batch them, and upload them. Okay, now that we have a rough understanding of what's happening inside the vehicle, we can zoom out to this overview of the life cycle of telemetry data from the vehicle, well, to us, the people that are building products on top of this data. The first step, obviously, is the vehicle itself with the CTP that gathers the sensors data and transmits it to the cloud through mobile networks. We then have an entry point in the cloud, in our case it's Azure, that receives this data and routes it downstream. This data is then ingested, and there is a first set of business logic rules that will route a subset of this data to interested business units. And finally, we have some layers of data processing using data of particular business units, which we build on top of it by processing it, persisting it, enrich it, and making it available for downstream users. In this line of business, downstream users are what we typically call fleet managers. They are an entity responsible to manage the day-to-day activity of buses and or truck fleets, and for that they rely on data insights, like we already spoke, like location-based services, automated trip detection and analysis, and many more. This is where we are going to focus today in our session, as this is one of the core activities at tblx, processing telemetry data from vehicles in order to perform real-time data analysis. And I'm going to pass to my colleague Carlos now.
Hello everyone. So the use case I'm going to use as a basis for the rest of this presentation is how he handled real-time analysis data at Daimler Buses Europe. So we have this near real-time data arriving to our systems, and we need to bridge the gap between road telemetry data and some useful information to provide value to fleet managers. And what we mean by useful information, it's things like, is my driver going over speed, or did my driver cross a border between two countries? So fleet managers often rely on traditional methods, with many still using paper, making operations labor-intensive and inefficient. Our goal is to deliver digital solutions in the standard way, simplifying fleet management tasks and making operations easier and more efficient. Based on this, our vision is a product that enables a precise data analysis to streamline the delivery of digital solutions to fleet managers. And here we have some requirements like it's to be stateful and use GVM or beyond or open source, for example. So to simplify, this is how the data flows through the system from a very simplified point of view. We consume some signals and then we pass them through a custom rule engine that does some data enrichment and computes some rules using Flink. With that, we produce some events that are consumed from a diverse set of applications. So, as you would expect by now, let's focus on Flink. Our product is composed by a Flink app where we run an in-house built rule engine. These rules are something like, is my driver going above the speed limit, or did anyone press the stop button on the bus? Developers can contribute with rules where patterns are actually analyzed, and the output events are then grouped by something we call services, like geofencing or EV, vehicle health, etc. So, simple doesn't mean easy. How did we get here? We need to give you a timeline of the product in order for things to make sense. We started with a POC without Flink, then we moved to Flink. After that, that's where the Halo jump happened, and since then we did a European expansion, and we are now working on a global setup. So let's start with a proof of concept. Like many projects, we started with a standard stack, with a very traditional stack like Spring Boot, Kafka, and a database. It got good adoption, but we quickly realized that we needed a more complex data manipulation framework than what we can do with Java. So, and pushing the rule engine state to a database wouldn't work in the long term. So we decided to move to Flink. And to do that, we looked into the industry standards for streaming, processing, and at the time, these three stood out, like Kafka, Flink, and Spark Streaming. We choose Flink, and why is that? Well, it meets our low latency real-time analysis. It's true event-based and stateful, and primarily we have a streaming use case with a small batch processing needs. We are confident on Flink long-term viability, and Flink is aligned with the team's engineering practices. Like, we can put Java developers in the project and they will figure out quickly. Moving on the timeline, this is where the Halo jump actually happened, but first I need to tell you why. In 2021, the Daimler Group decided to split the commercial vehicle segment from the passenger car segment. Daimler Truck was created as a new entity listed in the stock market, and with that, the IT department also got split with some teams moving to the other company. And within Daimler Truck, some positions got vacant since some of those teams are now part of Mercedes-Benz passenger cars. One of these teams was the team working on the bus's rule engine. That's where our team enters. Our team was already had the previous experience with managing a Kafka cluster, and we work in a true DevOps setup where we develop and operate the infrastructure. So we were brought in to keep the data infrastructure stable and performant. With that, we include the Apache Flink cluster. We also had the responsibility of promoting good practices like CI/CD, infra as code, observability, alerting, documentation, etc. Going back to Fabio with the Halo jump.
Okay, so as Carlos explained, and you know by now, the company got split, and we had to fulfill a gap in terms of development and operations. In that context, we basically had to Halo jump, obviously it's just a joke, into this Flink application, because we didn't have any previous Flink experience. So things like job graph, checkpoints, operators, key by operator, cryo were completely new to us, and we had to make some effort to learn them. So we want to share with you what we would like to know before the jump about Flink. The next slides are not really a Flink tutorial. Obviously, you have very good documentation for that, but just a set of foundational concepts that we consider important to know before starting to develop a Flink application. Okay, one of the first very good things that we need to understand is that Flink has multiple levels of abstraction to interact with, okay? If it's enough for you, you can process your event streams with simple SQL. We've already saw some examples in the conference with that. But we think that if you are working with Flink, you should have a deeper level of understanding and try to leverage the data streaming API. Okay, so we also believe that working with state requires a mentality change. Most of the backend development out there are stateless applications. They simply persist data to storage and can be safely restarted if something goes wrong. Stateful applications like Flink are a bit different. They keep track of their internal state, so restarting or changing them isn't always safe. So we need to be extra careful with the changes that could affect the state.
Всем
And
привет.
as such, when
Значит,
developing
в основном
applications
был на
statefully
конференции
like
Current
Flink, we believe it
2025.
requires a
Потом
conscious
удалил
mind to
поле
keep
для
these
пальты.
constraints
Задачу
in mind.
сделал,
Okay?
посмотрел флинки, что там,
Okay,
какие
since state
результаты.
is at the core of
Вот,
how
была
Flink real-time
коммуникация по
applications
Common
work, it's
View
crucial to
с
understand how to
парнями,
manage
с
it
Варом и
properly.
Ильей. Был
Managing state
ресерч по
efficiently
Вальту
means not
после
only knowing
хотфикса,
how to
и
store and
вот
access it, but also
выбрали
ensuring it
стратегию,
remains
по
consistent,
которой
scalable,
тестировать.
and fault
Сегодня
tolerant.
вот дорабатываю
Regarding
как-то
fault
сендер,
tolerance,
чтобы
Flink offers two mechanisms
можно
out of the
какие-нибудь
box that we
EPS
will
бешеные
discuss a
туда
bit down the line,
всовывать.
but it's
У
called
меня все, спасибо.
checkpoints and save points. Okay, we are talking about state and how important it is, but what is state actually? Essentially, and just to simplify, state is the objects that we have in memory being serialized and stored by Flink in what we call a state backend. For the serializers, you have a few options that you can use, like the Avro serializer, Cryo, Custom, and some more. As I said in the last slides, there are two concepts regarding fault tolerance, checkpoints and save points. And although they look very similar, they serve different purposes. So checkpoint is the core mechanism for fault tolerance in Flink. They are created automatically and are used to recover the job in case of failure. While on the other end, save points are triggered or scheduled by us, and we use them for operation flexibility, like deployments or upgrades. I won't delve too much regarding state backend, but we just wanted to share with you as we feel it is important. And now going back to Carlos for some stream processing logic.
So it's important to distinguish between event time, the moment the event occurred, and processing time, the moment when the event was actually processed by Flink. We all know that time can be relative, but in stateful stream computation, this requires a special treatment. Imagine that for some reason, the system starts to have lag for 20 minutes. Then we scale up the system and we process those 20 minutes of lag in 3 minutes. If we use the incoming events to measure the hap time, the entire system needs to be ready to accommodate that and be very careful when mixing the processing time and the event time. So watermarking is Flink's support for event time. To simplify, watermarking is Flink's way to tell that time progressed, and it helps handle a lot of the out of order events. Watermarking can get complex. We will not delve into it, but we encourage you to look into it more deeply. Operators, as the name implies, are what we use to apply transformations to data, similar to normal Java streams, but on steroids. When you compose multiple operators, we are basically describing your business logic and actually creating the job. Like we said previously, with state, working with state requires developing with state in mind. We don't want to block critical operations like checkpointing. And there are situations where we need to call external sources, and for this we recommend using the async operator to avoid blocking the threads. Here we have an example on how to use it. Depending on your use case, you might want to partition the data processing. In our case, we need to partition the data per vehicle. Flink helps us do that out of the box with the key by operator, where we split the streams by vehicle ID. Behind the scenes, this creates a keyed state that guarantees consistency and isolation per vehicle. When you finish describing your the data processing logic, Flink will create a job graph and an execution plan. The job graph describes the business logic that you are applying to your data, and the execution plan is the concrete details about how Flink will run the job, such as operators and parallelism. This is an example of a job graph where the Flink data pipeline is somehow described. You can easily obtain this via the Flink UI. So back to Fabio.
Okay, so we have established some foundational concepts that after these years we believe are essential for you to know about Flink, but let's go to why we are all here. How has it been the experience of self-managing a Flink cluster? Okay, first of all, why are we managing our own Flink cluster? When we started, the cloud offerings weren't very mature, in our opinion. We always tried to use the latest Flink version, and we have enough operations experience to do on our own, to be honest. So nonetheless, there are still some pain points of self-managing a Flink cluster that we want to share with you. Some of them is that it requires a lot of work to keep everything working and up to date, and fine-tuning every aspect of it might get a bit complex. In the beginning, we used to do everything manually. We created our own Helm charts, did the Flink deployment, scaling. The CI/CD process got a bit complex with some upgrades and deployments that we had to do manually, and it was a real pain to manage, to be honest. And once we start using the Kubernetes operator, things got much easier. Operations became simpler, and Flink became more stable. So having managed a Flink cluster both with and without the Kubernetes operator, we strongly recommend you to do it if you can. Here's an example of how easy it is to configure the Kubernetes operator. Things like automatic save points now become available out of the box, and the overall configuration is just easy. On the screen, you can see how we are configuring Flink's tolerance mechanism, just as an example. Here we have some more examples of configurations done via Helm files. Things like monitoring, task manager, and job manager configuration are pretty straightforward, as you can see. But I do want to note that although the Kubernetes operator is great, fine-tuning, again, might require some work, but not as complex as before. And the auto-scaling is still not perfect. Okay, this one is a bit obvious, but we still like to emphasize. So monitor everything, and I hope you guys are doing it. It is almost close to impossible to manage a cluster like this without proper visibility. Ensure you have full visibility into the internals of your job. Here we have some dashboards with some metrics that we find important, but there are many more. For example, you need to know the volume of data going in and out of the system, the lag of the system, job restarts, back pressure, the usage of task manager, CPU, and obviously, last but not least, and one very important aspect, keep track of the fault tolerance mechanisms like checkpoint duration, failed checkpoints, checkpoint size, and save points. Okay, as everyone knows, scaling is crucial for everyone working under high load. There are two methodologies to scale, vertical scaling and horizontal scaling. Vertically, you simply increase the resources of the application, and horizontally, you increase the number of replicas. Before the Kubernetes operator, scaling was not so trivial, and although the Kubernetes operator still helps with the auto-scaling, fine-tuning might be complex, but here we share a potential configuration that you could try out. Okay, going back to state, and to reiterate how important state is, most of our incidents were related with state issues. We had 12 incidents since 2022, 8 were related with state. We lost offsets, we also lost full states. Things like class loading issues and schema compatibility issues happened. These are some of the examples we had. I can recall one bad example, like we had a class being serialized as null, which led to a null pointer exception being thrown in a task manager, which caused a job to restart, and we enter a restart loop. Okay, so at the beginning of the presentation, we said that state are serialized objects, and we present some serializers that you can use. Our experience tells us that choosing the right serializer is very, very important. We started with Cryo, and at first it felt great, easy to adopt with minimal configuration, but we ended up having performance issues and lack of schema evolution. Moving away was really challenging and time-consuming, so please consider alternatives to Cryo. And passing on to Carlos to continue with the learnings.
So order is very important to us because of the rule engine, and the sequence of events is very important. And this is not 100% Flink related, but is something that you should consider when developing Flink applications. Although Flink provides some solutions to keep events in order, it's much easier if you can have the data sources aligned. And why is that? If you need to process the events, it is important for them to be consumed in the same order as they did initially per partition. Make an effort to make your downstream systems idempotent. If there is a system trailer, Flink will restart from the latest checkpoint, and you might get duplicate events. If you are dealing with a lot of data, this can be problematic. And how can you do it? You can try to create predictable event identifiers to filter out duplicates. If possible, filter out by timestamp, and or make the entire system transactional. But this is much easier said than that, because downstream event systems might not be under your control. Don't look up, and you can look up during your job, but do it carefully. Make sure you are using the proper operator for it, which we spoke about already. It's the async operator. Imagine this. You make an HTTP request. That HTTP request takes too much time, blocking the main thread, and causes the checkpoint to time out, making the job to restart. We learned this the hard way in 2023. We had an unusual spike in the incoming data, and we were not using the async operator. It blocked the threads, and we got into a crash loop. There are some limitations with state. When persisting to the state, sometimes things can't be changed, like the max parallelism or the cryo-serialized objects. If you actually need to change those things, you need to leverage the state processing API, which is a low-level API used to manipulate the state. This is why we said that it got complex to move away from cryo. Again, this might sound obvious, but test everything and leverage the Flink built-in tools for testing. Flink provides the test harness collection that you definitely should use. And for end-to-end tests, you can use the mini cluster. But you can also develop in a way that makes tests easier to code. As a suggestion, we think that you should use the version of control pattern to define the data pipeline. Here we have an example on how to do it, and then when you are actually doing your code, it will be easier to inject data and read data. You should also practice a defensive programming style. While this is a very generic advice that applies to any application we build, it's especially crucial for when we are working with Flink applications. And why is that? Flink considers any uncaught exception as a failure, which in turn triggers a job restart. And this causes Flink to revert to the latest checkpoint and begin reprocessing data from that point. If not handled properly, it can lead to a continuous restart loop. Keep up with the latest versions. Keeping up with the latest versions is totally worth it, the development cost. Flink is always evolving, and we have found that the gap between versions can be significant, and skipping them is too costly. So we advise you to keep up to date. So this is not an actual learning per se, but a challenge we faced. The reality is that there is a lack of good Flink examples on the internet. Most of the articles are only superficial and won't delve too deep into some complex topics. Plus, the official documentation, although it's good, it's very extensive and not very beginner-friendly. And sometimes we feel we are working in a niche technology. And when comparing to other mainstream frameworks, we see a smaller community and overall adoption. As you can see in the metrics we got from Stack Overflow and Git star history, Flink is well known than other frameworks like Spark or Kafka. And from Google Trends, we see the same thing. it might not be as popular, but it's still totally worth it to learn it and use it in production. So, back to Fabio.
Okay, guys, so to sum it up, these are the main takeaways from our session. Keep an eye on everything. Good monitoring will save you a lot of headaches later. Take time to understand how Flink works under the hood. It will make your life easier when things go sideways. If you can, please use the Kubernetes operator. It really helps with managing deployments and overall configuration. And like Carlos said, stay on top of new releases. The Flink team ships solid improvements regularly.
Should also look into alternatives to Cryo. It's decent, but not always the right tool for the job. Don't let the learning curve freak you out. It's a lot at first, but it will click over time. And Flink can be tricky, but it's totally worth it from my perspective. It's an amazing tool to have under your belt. I know it was a lot of topics. Let us know if you have any questions. Thank you, and hope you liked it.
Thank you very much. Do you have any tips on sizing your Flink cluster or estimating how big to make it?
There's I think a lot of variables going there. The way I would do it is measuring, of course, the incoming data into the system. How big are the events, and which serializer are you using to serialize that data from Kafka? Because what I've noticed is like a big chunk of the computing power that we are using is just serializing the data that comes from the vehicles. So using the serializer, the correct serializer to deserialize from Kafka, and then the way you deserialize NL internal information is also crucial. And I'm talking about the serializer that to read from Kafka, and then the serializer to persist the state. If you are using Cryo, we are going to pay a very high bill in computing. It really does have an impact. Apart from that, I don't really have like a standard way to measure how it would work.
I mean, it was a bit of trial and error, to be honest. Like, we showed an example of the amount of events we have incoming to our system, but those events actually, they contain a lot of more data. So one event can contain like 300 data points that we then split. So inside our Flink cluster, we are around managing 500,000 events per second, more or less. So it was a bit of trial and error. So we started with, we believe it was good. And then with time, good monitoring, we started to increase until we got into a stable point, but really no good recipe to share, sadly.
Thanks for your presentation.
Thank
I have two questions. First, what are issues you faced when you try to use transaction? And the second one, did you use exactly one semantics? Thanks.
Can you repeat the first question?
The first question, what are the problems you faced when you try to use transaction? You said that there is some issue. And the second one, exactly once did you use it? Thanks.
So, just to make sure I understand, the first one is which issues did I face when working with transaction? And if I were using only once semantics, correct? We are not using only once semantics. The thing with transactions is that I need to make the entire system transactional from the entry point to the end point. And the way the setup works is I do not have control over the incoming data or that system, and that system is not transactional by default. So I cannot have transactions at the reading point. And I can also not have full control of downstream systems. So I can only work inside this gap here with Flink. The best thing I can do is somehow make it easy to remove duplicate events for downstream systems.
Just to clarify, it's not a technical challenge, it's just that other teams within the company and other groups are working on different parts of the system. Okay, and that's why Carlos said it's easier said than done to make the whole system transactional.
Hi. We've been on a similar journey over the last 8 or 9 years, so I have a couple of questions that are kind of related. How real-time do you need your analytics? And secondly, how much state do you have? Because I saw on one of the slides you're using periodic save points, and larger state applications will essentially slow down what your users are seeing. So yeah, how real-time and how are you managing that periodic save point with large state?
Okay. Regarding the real time, I believe our SLA is below 5 seconds from the vehicle to the end user. Okay, we are way below this as far as I understand, but it depends on the type of events we have. So how the way our rule engine works, there are some events that do triggers. So there are only triggers that happen after a few hours or something like that, and those we don't have SLA. But for the real time, like geolocation, it's below 5 seconds. What was the other question? Sorry, regarding save points.
I saw on one of the slides you're using periodic full save points, but obviously with large state applications, that creates a bit of a back pressure on the rest of the pipeline whilst it processes the full save point. So that's going to delay what you're sending downstream to the users. How are you handling that? If you're, I think you said, maybe it was just an example, but you were running them every 1 hour or something.
Yeah, no, it's a real production example.
Yes, so we use the operator to trigger the automatic save points. It's just a configuration. And the impact that we have on taking the save point, it's actually not that big. The internal state of the application, because we are the ones developing the religion as well, we have full control on what is serialized and what we need to serialize to make the religion work. And it does not have an impact on our system.
Hey, thank you. Great talk. But I'm very interested in one thing that what use cases do you solve with this Flink, right? You showed some questions that you were looking answers for. Are these the use cases that you succeeded in implementing? Maybe you can shed some light.
Yeah, we can, because these products are actually publicly available, so we are okay to talk about. So this platform itself, the rule engine, is just an enabler for digital products, right? So we provide the platform, and then other developers can provide services with these rules. Some services that we have, for example, is the geofencing. So let's say you own a fleet of trucks and you don't want them to leave Germany. If they leave Germany, we produce some events. Look, you got out of Germany, to the fleet manager. Other example for driver performance. So drivers are evaluated on how good they are driving, like accelerating, if they are stopping, if they are making bad turns, wrong turns, stuff like that. So we don't have the specifics on those services. Our team, we provide a platform for other developers to build those services with some logic, math behind, stuff like that. Okay.
Okay. I will limit to one more question. Yeah. I would love to ask more. The common problem, right, in processing IoT data with Flink, especially, right, is that there's a lot of vehicles, right, thousands, maybe even more, and each of them sends data, and they might be late, right, as well. There might be network disconnection, and you might not receive data, and then the watermark strategy fails, right? So because so a lot of people are looking for example, having watermark per vehicle, which is not possible with Flink. Do you encounter this problem? Do you solve it somehow?
We encounter it, but we haven't solved it yet. We are actually on the process of solving it. So the way we are going to solve it is by reprocessing data from a predefined timestamp. Okay, so the technologies that we are using allows us to go back in time, let's call it like this, because on Kafka things are like 7 days retention. We are actually using event up, so we can set an offset. So we are just discussing on how we are going to do it, if we want to use save points to have the same state at the time. But we have that problem in some vehicles, that some data is either not arriving in order or not arriving at time for whatever reason. And yeah, we haven't solved it, but we are going to do reprocessing of data to solve it, or at least to try to tackle that issue.
Okay, thank you.
Thank you so much for the presentation. you mentioned really nicely that you started with a POC where you weren't using Flink, and then you considered Spark Streaming, for example. What was the main reason for you to choose Flink over the other options?
Because our use case is mostly streaming and not batching. We only have small batching needs, and Spark, from what we gathered at the time, was mostly for batching. But
We also have the Spark streaming, but it's like micro batching, and that was not the real use case we wanted. And also the Spark development, the way you code your jobs, sometimes is not easy to start at the beginning. And we felt that Flink was easier to understand. It might be an understatement at the time, but it feels more natural to Java developers. At least that's my opinion. It's closer to Java streams, and it's easier to understand. And it's actually stream-based. It's not micro-batching. And you need to also have experience managing a Spark cluster and all that stuff. Or you can pay someone to do it, but it was mostly that. And also the way we have a rule engine working on top of Flink, and the way we serialize the state and the way we keep the state of the rule engine in memory, it was easier for us to come up with a concept where we said, okay, we can deliver this solution.
I got a question here with regards to the rule engine. So is the rule engine actually translated into Flink jobs? And if that's the case, like what happens, for example, whenever your rules change? Like with respect to the operators, maybe you have like new ones, and then how do you actually tackle them later on, like the Flink job operates, for example? Do you have to reprocess or?
So let's say that one rule changed. So the way I cannot specify too much how does the rule engine works, but it's a Java application that we instantiate per vehicle. That's why we use the keep-i operator. But it's a very simple, not very simple, but very thin layer of code, okay? And we only persist what we need to keep the rule state into memory. And when a rule changes, there's some code that you need to change in order to migrate the latest state to the new state that you want to work with. Let's say that you change an int to a float. If you try to serialize it, it will fail. So there is a specific abstraction that let's call it a migration code, that you need to map that value. And then in the test, if you do not have it, it will fail.
And then with regards to like the Flink job, do you actually just reprocess everything, or you just pick it up from where it is?
Basically, yes. So that's why you need some. It's not only the Flink job. You then have extra tooling to help you manipulate all that data that is duplicate or that you might want to discard. But yes, it was like millions of events per second being discarded. But yes.
Hey.
You said you did scale out from regional to Europe to global. Did you face any major challenges scaling your system to global availability?
I mean, we are still on the process of doing it, okay? So talk again in 2 months and I'll let you know. But I mean, I don't think we'll face much challenges because we are probably going to just do isolation zones, right? So we'll probably deploy in America a totally different solution that we deploy in Europe or in Asia. So I think it will be isolated. We already have many solutions working like this, so I don't foresee any big challenges because we don't need to update the state worldwide. So.
Thank you.
Yeah, thank you very much for the talk. It's nice to see others going through the same journey that myself and my colleague here have been through over the last year or so. Our first Flink job we've built mostly in the table API, and we are finding some limitations with that and considering going down to the data stream API. So I presume you guys are seasoned Java developers. How have you found working with like state, for example, within the data stream API sort of how long did it take for it to just, click and become, second nature? So what is your experience of coming in fresh and going into the data stream API, I think is my main question.
Well, I cannot, I don't want to say that it's easy, but I also don't want to say that it's hard. It depends on how familiar is your team with the Flink ecosystem. Once you know, like, okay, I need a state, I have a state that I need to be very careful when serializing and deserializing, and when I'm deploying something, I need to make sure that the state will not break, otherwise I will start a restart loop, and there's nothing I can do besides trying to redeploy again from a safe point. So once you are familiar with the operations, or you have someone that is very good with it, your developers only need to know the development tools like operators, how can you enrich data, how can you broadcast, how can you, so you change your mentality as a developer. You need to know, I'm working in streaming, in a streaming way. It means, okay, there's no easy lookups, everything needs to come as an event, plus it's stateful, meaning everything will get into the state. It's not like processing a Kafka stream or a normal Kafka topic with a Java application. You are doing that, plus keeping your internal state. And that is what I found more challenging to pass to new developers. It's changing that mentality, okay, I'm processing this and I have state. The rest of the things like, okay, which operators can I use? How can I test it? How can I monitor it? That's easy to understand from the documentation. But the mentality change of, okay, I'm streaming and I have a state, and the state, it's not like something I persist to a database on a normal API. It's like our internal variables. That's something that I find hard to explain at the beginning, and it comes with time.
Thank you.
A very interesting aspect is that you actually provide a platform for other users, right? Mm-hmm. Do you provide just a raw platform where people are coding in IDE, in Java, the applications, or do you try to build some kind of like a higher level tool with a DSL, maybe Flink SQL, maybe some other means to deploy the jobs?
Okay, so right now they are only developing in Java, but the next step is actually that. So we are probably going to build some kind of UI, like low-code solution where people could probably drag and drop stuff, and then we have something in the middle to translate into rules. That's actually on the roadmap as well.
Thank you.
Thank you.